So, the worked example now, again, these are all from the book. So we have a vehicle towing a caravan, accelerates at 1.8 meters per second squared in order to overtake a car in front. The vehicle's mass is 2,700 kilograms and the caravan's mass is 2,000 kilograms. The drag forces on the vehicle are 1,100 newtons, while the drag forces on the caravan are 1,500 newtons. Calculate the thrust of the engine. Okay, what's the first thing we do?
Draw a diagram.
Draw a diagram. All right. Now, unfortunately, you have to see me draw a car. Let's see. There you go. It's like Van Gogh, right? And then a caravan. Ah, look at that. Just champagne stuff. Okay, so there's our diagram. We have drag forces on the vehicle are 1,100 newtons. So we have a force backwards, of 1,100 newtons. And we have a force on the caravan of 1,500 newtons. Okay, so these are our frictional forces, or drag forces. So that includes friction and air resistance. Okay, what other information have we got? The caravan's mass is 2,000 kilograms. And the vehicle's mass is 2,700. Sorry, this is small. Hopefully you can read that. All right. What else have we got? We've got an acceleration of 1.8 meters per second squared. Okay, and so we want to know the thrust of the engine. Okay. Now, if we look at our forces, okay, let's actually do this in a let's do this in a simplistic way. And actually, this is the way I want you to start thinking about these problems. Okay. Is there a net force acting here?
Yes.
How do we know? It's accelerating. Good. So first things first, let's work out the net force. Okay? Newton's second law. So our net force is going to be equal to ma. Okay? Now, actually, we can write this a different way. Well, not different, but just... What does that mean?
Total mass.
All the masses summed together. Absolutely. So our net force is equal to the net mass multiplied by the acceleration. Okay? So, our net mass is 2,700 plus 2,000. So 4,700 multiplied by 1.8. I brought a calculator today. If someone's faster than me, go for it.
60.
460? 460, thank you. 8,460 newtons. That is our net force. Okay, so all our forces added together give us 8,460 newtons. So anytime you have an acceleration, that acceleration is caused by your net force. Now this net force, we need to work out what that net force is comprised of. What is it? What are the forces acting here? We've got the drag forces. Good, so the drag forces are pulling it backwards. What else have we got?
The engine pulling forward.
The engine thrust pulling it forwards. All right, excellent. So, our net force, I'm running out of room. I might just dip into part B here for a second. So our net force is equal to our thrust force plus our frictional force. Okay, so all our forces added together. Now the only trick to this is you need to be a little bit careful with your signs. Remember, in physics, plus and minus are just directions. Okay, so we know that our net force, well actually let's rearrange this. We are looking for our thrust, which is going to be equal to our net force minus our frictional force. Okay, so we know that our net force is 8,460 minus our net frictional force is going to be 2,600 newtons. Now, the thing to be aware of here is we are accelerating that way. Our net force is going forwards. Our frictional force is going in the opposite direction. So, we need to have our frictional force as a negative. Okay, does that make sense? If to the left is positive, so that 8,460 is positive, the frictional force is acting to the right, so that must be negative. And so we are subtracting a negative here. Okay, so it's too early for me to do that in my head. 8,460 plus 2,600. And so we get 11,060 newtons. Okay, so that is the thrust of the engine, 11,060 newtons. Now, another way to think about this is our car's engine, the thrust, is applying 11,060 newtons. It has to overcome the 2,600 newtons of friction. Okay, so that 11,600, it has to overcome this, right? So if we've got 11,600 pushing in that direction, and we have 11,060 to the left, we have 2,600 to the right, if we add those together, you will get your net force. Okay, so the thrust has to work harder than usual to overcome the frictional force. Okay, so this sort of problem, it's not that difficult. You just need to think that if something is accelerating, it must have a net force acting on it. Okay, just keep that in mind. We have an acceleration here, we must have a net force. Okay, the next thing, the tension in the coupling, and this is where people get confused. The tension is just, what I want you to think of is the tension in the coupling is pulling the caravan forwards. Okay, that's what that tension force is. The tension is pulling the caravan forwards. And in fact, let's ignore the car in part B. Okay, let's completely ignore the car. And in fact, I'm going to draw it down here. So we have our caravan, which is 2,000 kilograms. It is being pulled forward by a tension force. Okay, we can ignore well, not ignore, but we can disregard thrust at the moment, because we worked out the thrust up here. If you just look at the caravan, if you be the caravan, right? If you are the caravan, all you can feel is something pulling you forwards, and that is that tension force. And that's what you're trying to work out. All right, caravans don't have eyes, so you can't see the car in front of you. All you can feel is that tension force pulling you forwards. Okay, so we have a tension force pulling it forwards. Now, the other thing we need to be aware of is we have an acceleration. Okay, our caravan has an acceleration. So again, remember, our net force is equal to ma. So, our caravan's mass is 2,000. What's the caravan's acceleration? 1.8. What's that? 3,600. So anytime you have a tension question, ignore what's doing the pulling and just look at what is being pulled. Okay, that's the best way to do these things for tension. Ignore what is doing the pulling, just look at what is being pulled. Okay, so our caravan is being pulled, and it has a net force of 3,600 newtons, but we also have this 1,500 newtons working against it. Okay, so again, from our equation on the left here, our net force is going to be equal to F tension plus our frictional force. Okay, we know our net force is 3,600. We know our frictional force is 1,500. So if we rearrange this again, our tension force, oh, my writing's getting small, sorry, is equal to that minus that. And I won't put the numbers in because I've run out of room, but our our net force is 3,600. We have to add the negative 1,500 to get 5,100 newtons. Okay? Remember, if these are in opposite directions, you need to be aware of the sign. Okay? So, if we have a positive 3,600 tension force, we must have a negative 1,500 frictional force. Okay? So this is all you need to remember with these sorts of questions. Okay? So basically, 2 points here. If you have a net acceleration, you must have a net force. Okay? And usually when you're doing a tension problem like this, the first thing you have to do is work out the acceleration of the whole system, or work out the force acting on the whole system. After you've got that, then usually they'll ask you to do something like this. Work out the tension in something. In that case, disregard what is doing the pulling and only focus on what is being pulled. Okay? Nice little mantra for you to remember. Caravans don't have eyes. I want you to think of that anytime you're doing tension. Caravans don't have eyes. It can only feel that it's being pulled. Okay? Go home tonight and tell your parents that your physics teacher says caravans don't have eyes. Watch what they say. All right.